Recap of what we learned yesterday. Okay. So, do you guys remember what we learned yesterday? Exponents?
We learned exponents.
Exponents, yeah? Alright. So, now when you say exponents, this is an example exponent, x to the power 2,
Yeah.
2 to the power 8,
Yes.
3 to the power 9,
Yes.
1 to the power 0.
Yes.
It's an exponent, yeah. The power value is 0, but it's still an exponent, right? The same form, yeah. Now, what we learned was there were three things: multiplying the numbers with exponents, dividing the numbers with exponents, and there was something called power of exponents, yeah. So, if we have 2 to the power 3 multiplied by 2 to the power 2. How much that will be? Do you guys remember? And do you guys know how to do it? 2 to the power 3 into 2 to the power 2. How much that will be?
4 to the power of 6.
No. See, what
2
happens?
to the power 6. 2 to the power 5.
2 to the power 5. Your base, if the base is same, you keep the base, add the exponents. So 3 plus 2. Okay? Now, let's say if you have to multiply 3 to the power 4, 3 to the power 6 into 3 to the power 5 into 3 to the power 8, how much that will be?
19 to the power of 3.
Is that the other way around?
Sorry, 3 to the power of 9.
19.
9.
Pranav, do you agree?
Yes.
Okay. So you guys remember what we learned yesterday. Now, if I say how much that will be? 2 to the power 3 into 3 to the power 2.
5 to the power of 5 to the power of 5.
No, that was a trick
9
question.
to the power of 5. 9 to the power of 5.
No. Don't do that. Don't.
6 to
No, don't do that. Don't ever do that. That will be a mistake. Okay? See,
Do you literally multiply that?
No, you don't. You don't. Okay? So don't do that. So exponents are useful when you are looking at the same base. If the base changes, you don't do any magic with that. You do simple multiplication. 2 to the power 3 is 8 and 3 to the power 2 is 9. If I have to solve it, this is what I will do. I will not multiply 2 by 3 and then add the power. No, that will not be a mistake. That will be a crime. Okay? Yeah? So what I'm saying is, when you are dealing with exponents, deal with the exponents only when you see the base is the same. If the base is different, it's a normal multiplication or division, whatever it is. Okay? Exponent is only a smarter way of dealing with the numbers when your base is same. Okay? So always be watchful, always be mindful of what you are doing. If you have this into 2 to the power 6 into 3 to the power 2, if you have something like this, what will you do here? You will use the technique that I always talk about. Tran, yeah? And this is the most important part of Tran. This is the brain of Tran. Analysis. This is when you read this, then you see, okay, fine. From this what I see is 2 to the power 3 and 2 to the power 6. This has common base. This is a different number, different base. Okay. So I'll have to treat them differently. That is your analysis part. And you'll say, okay, here, yeah, you're saying something.
What's the middle number?
2,
But
2 to the power
No,
6.
2 to the power of 6. Okay.
Yeah.
And because we couldn't see it.
Okay. Yeah. Because of the reflection. Yeah, so you can ask that, okay? But the video that I'll upload, that will have a much clearer picture, okay? Don't worry about that.
Okay.
So, here, in that phase A, the analysis phase, what you will do? You'll say, okay, fine. Here, my 2 and 2 are the same base. Here I can add the exponents because I'm talking about multiplication. This is separate. I will not add them. That is what you'll do as part of analysis. And then comes Nike. When you say, okay, fine. 2 to the power 3 and 2 to the power 6. This I can treat separately. So it becomes 2 to the power 6 plus 3 into 3 to the power 2. So this is 2 to the power 9 into 3 to the power 2. Now you can break it, multiply it, whatever you want to do, but don't use exponents theory here. Okay? Yeah? So this is another one.
Yeah.
Now, so here what is most important? Make sure that you read the question correctly and ensure that your bases are same if you are dealing with exponents. Okay? If the base is different, don't treat them like regular exponents. Okay? At least don't apply the formula that we have learned. Then comes, how much is this? Do you guys remember? 3 to the power 8 divided by 3 to the power 2.
Is it?
Yeah, go ahead. Now,
Wait, I think I know.
but now do you remember?
3 to the power
3 to the power
3 to the power 6.
6, yes.
Of 6.
Yes. Now, the simple thing is, when you are multiplying the exponents and your base is same, you add the power. When you are dividing the exponents and the base is same, you subtract the power or the exponents. That's what it is. So that's what you did. Yeah? You said, okay, I am dividing, both have the same base. So I will put this. Whatever I have in the numerator is power minus whatever I have in the denominator. And that is how it became 3 power 6. Yeah?
3
Okay?
to the power 6. I just did it the long way. Then
Yeah.
I got 3 to the power 6.
Right. No, so that long way is the most authentic way, but that may not be the efficient way, because if somebody says like this, okay, so get this, if somebody tricks you and says find out 3 to the power 928 into 3 to the power 8 divided by 3 to the power 816. If you do it the long way, it will be really long. Yeah?
Yes.
So that is where whatever we have learned with exponents, that will help. So, okay, now without doing it the long way, can you guys solve this for me and tell me what the answer would be? 3 to the power 928 multiplied by 3 to the power 928 into 3 to the power 8 divided by 3 to the power 816.
Is it 928? I multiplied by 3 to the power of 8 and divided by 3 to the power of 816.
Yes.
I got my answer.
What is that?
Sir, what is it divided by?
3 to the power 816.
Okay. I got my answer.
What is that?
3 to the power of 6,608.
3 to the power 6608. That is not correct. Do it one more time.
Okay.
I mean, why I'm saying so is, this is not a difficult problem, okay? This is an easy problem. You have to just apply all that you have learned and try doing it step by step. Don't do everything together, okay?
Sir,
Try
I
it.
got my answer.
What is that?
3 to the power of 128. No, 120.
120. Yeah, that is the correct answer, but I would wait for Gitesh to finish his calculation before we kind of revisit this one.
I got the same answer.
Same answer. Do you know why it was wrong last time?
No, I got the exact same answer I got last time.
Oh, okay. That means there's something that we are missing here.
Yeah, this is what I've done. I've done 928 multiplied by 8.
You will not. You will not do that because your base is the same. Now remember, we did this 2 to the power 3. Yeah?
We have to add it, right?
Yes.
Yes.
So when you multiply exponents, so this comes with practice, okay? Nothing wrong with what has happened, okay? It's just a minor oversight and your answer could differ big time. So here, only thing that you have to remember is if I'm multiplying two exponents and my base is same for both the scenarios, I just add the exponents. My base remains the same. If I'm dividing one exponent by another one and my base is same, I subtract the exponent from numerator to denominator. So here, in the first step you did multiplication. So let's say we will not do division in the first step. Here you did multiplication, which makes it 928 plus 8. So in the first step you did multiplication. That gives you 3 to the power 936 divided by 3 to the power 816. And always when you are doing math, do it like you are telling a story to somebody. You are explaining it to somebody. Okay? See, what did I do? First step, I am doing multiplication. So there were 2 3's, I made 1 by using exponents. Okay. Now that means this. Now here in the next step I'll say, okay, now I have 9 to the power 936, 3 to the power 936 divided by 3 to the power 816. That means the base is the same, so I will subtract. And that is how I get 3 to the power 120. Yeah?
Yeah, no, I did it again with addition instead of multiplication and I got
Right.
3 more.
Right. So these are like one-time learning. Okay, so you will learn it once, apply it while doing practice, and then you become a champion in this. Okay. Now there is another flavor of exponents that we learned yesterday. We'll try not to learn all things today. It's a smaller class, and we don't have many kids here, and we'll just make sure that we focus on what we learned yesterday, and we do some practice with that. Now, another thing we learned was this. Do you guys remember what is the value of this one? 2 to the power 3 inside the bracket, to the power 4. 2 to the power 3 inside the bracket, to the power 4. How much is that? Do you guys remember? Gitesh and Pranav, tell me when you are ready. If you know, please do it and let me know. If you don't, let me know that I don't remember. That's both is okay.
I don't remember.
Okay, how about you, Pranav? Pranav, do you?
I got my hands.
I'm sorry?
I know the hands.
How much is that?
2 to the power 12.
Oh, okay. So that is the correct answer. And let me just do a quick recap so that we are all on the same page. So when you are dealing with this, 2 to the power 3 to the power 4 or 3, whatever it is, what we end up doing is we multiply this by this. So 2 to the power 4 into 3. It's only in the case when you have power to the power, okay? You are adding double power. So you are multiplying, okay? When you are multiplying only two powers like this, you are adding, okay? So when you have power inside the bracket, you end up multiplying, and you will tell me why. It's very simple. If I say 2 to the power 3, let's say 2 is inside the bracket, and I say to the power 3, what it means? It means 2 into 2 into 2. So I am multiplying the 2 inside the bracket 3 times. Or I can say this is 2 into 2 into 2. So 2 inside the bracket means 2, nothing else. And then here's the thing. Same way, if I am saying 2 to the power 3 to the power 4, that means 2 to the power 3 is getting multiplied by itself 4 times. Okay? That means this bracket is of no use actually, it's all the same. So it becomes like this. And it ends up becoming 2 in 2 to the power 3 into 2 to the power 3, that becomes 2 to the power 3 plus 3 plus 3 plus 3, or you can say 2 to the power 3 into 4. Okay?
Okay.
So this is the calculation part of it. So these are three main types of calculation that you will deal with: multiplying exponents, dividing exponents, and then power to the exponent. Okay?
Okay.
There is one more. There is some interesting part of it. So let's do one more sum, then I will teach you guys something interesting about it. So if I give you guys 3 to the power 2 to the power 3 into 3 cube can you guys solve it? I have 3 to the power 2 inside a bracket to the power 3, something like this. Okay, multiplied by 2 to the power 3 divided by 3 to the power 4 into 2 to the power 2. Can you guys solve this one?
Okay.
Pranav, you got the question, right?
Yes.
Okay.
Is it 3 to the on the bottom? Is it 3 to the power of 4 or 9?
3 to the power 4. Are you guys ready?
Is it 6 to the power of 3?
6 to the power of 3. Okay, this is one answer. How about you, Pranav?
I got 18.
You got 18. Okay, so there are two answers, 6 to the power 3 and 18, and both are not same for sure. So let's see which one is correct, or if there is a third answer that could be correct. Okay? So, Pranav, do you want to tell me how you got 18? Just tell me the process part. You don't have to tell me the calculation.
Okay, so first I did 3 to the power of 2 in brackets, and then to the power of 3.
That becomes what?
That became 3 to the power of 6.
Okay.
And then I subtracted that by 3 to the power of 4.
Okay. So what I would suggest always, Pranav and Gitesh, is don't do too many calculations at the same time. Okay. So you said, okay, 3 power 2 to power 3 became 3 into 2 power 3 divided by 3 to power 4. Let's put everything else. Okay. Now, first one, what it became? This became 3 to power 6 into 2 to the power 3 divided by 3 to the power 4 into 2 to the power 2. Yeah? That's it?
Yeah.
Okay.
And then I subtracted 3 to the power of 6 with 3 to the power of 4, and I got 3 to the power of 2.
Yes. So basically you grouped similar things together, right? So you put 3 together, 2 together, right? So that is how you got 3 to the power 6 minus 4 into 2 to the power 3 minus 2. Yeah?
Yeah.
And that gave you 3 to the power 6 minus 4 is 2 into 2 to the power 3 minus 2 is 1. That is 2 to the power 1. That's what you got?
Yeah.
And that's what made it 3 to the power 2 is 9 into 2 is 18. So this seems to be the correct answer. Okay. So Gitesh, here in this process, where you think you might have missed? I'm just thinking, yeah.
I didn't know how to do it, sir.
Okay, no, so see, always assume we are doing what we have learned just now, okay? So don't keep anything to bother you in the mind, okay? This is simple, okay? We have learned three things today, or between yesterday and today, and I'm just repeating it, okay? It's just a matter of doing a recap, okay? If I am multiplying this, what happens is my power gets added. So this is one thing I have learned. This is one. The second thing is, if I am dividing, what happens? My power gets reduced. So 8 minus 6. I am subtracting. If I have something power to the power, I end up multiplying the powers. Okay. So there are three variants only. So here, if you look at this one, we have all the three flavors. I purposefully kept this question to make sure that we try all the three concepts that we have learned with the exponents. Okay. So first one is the power to the power. That one, we are just making it simple. See, whenever you have bracket, if you go by the order of operation also, right? First thing what we do, whatever is inside the bracket, we do that calculation first. And then we break open the bracket. That's what we are trying to do. We'll keep everything as is, we'll not touch them. Okay? So we are trying to break open the bracket. So whatever is there inside the bracket, let's calculate that first. We know that something to the power inside the bracket, and we have a power on the top of that, this power gets multiplied. So it will become 3 to the power 2 into 3. This is my new, I'm doing my calculation, right? So I'm just putting it like a story that okay, I broke this open and this is what I got. So that means 3 to the power 2 into 3 is 6 into 2 to the power 3 divided by 3 to the power 4 into 2 to the power 2. See, I have not done anything. Whatever we had here, I am just writing the next step, like I am telling you guys a story. Okay. Now I have this. So here, what you see, I told that when you are dealing with exponents, you have to always make sure that we are looking at the base. If the base is same, see this guy has same 3 as a base, this has 3 as a base. This has 2 as a base, this has 2 as a base. So what we will do? Similar things we will calculate together. So what I am doing here is 3 to the power 6 divided by 3 to the power 4. This one I am calculating together. This becomes 3 to the power 6 minus 4. Because this is a numerator, this is a denominator. When I am dividing, I subtract the power. Okay. Then the second part is what? This 2 thing. 2 has 2 to the power 3 and denominator has 2 to the power 2. This becomes this. So this is my next step. So now 3 to the power 6 minus 4 is 2 into 2 to the power 3 minus 2. 3 minus 2 is 1. So I got this. So that means 3 to the power 2 is 3 into 3 and 2 to the power 1 means 2. Now you multiply this, you get 18. So my only what do you call a recommendation, suggestion, advice, guidance to all of my students is that math, you have to look at it like a child. It is the most innocent thing. Math is never complicated. Math is always very innocent. We make it look crooked by overthinking about it. So don't overthink. Whenever a math comes to you or you come across a math problem, think of that as an innocent child who is asking you certain questions. And you have to answer that. Okay? I mean, again, I'm kind of making it look like what you call a fairy tale, which is not the case. But what I'm saying is, any sum that you come across, on the first go, when you look at it, it will look complicated. Read it once. Think about it. Spend 30 seconds with the math. You will see it becomes easier when you read it over and over again. That's what is my this R part. Read the question again and again. Trust me, if you have got a question like this, just read it blindly. Okay, 3 to the power 2 inside bracket to the power 3 multiplied by 2 cube divided by 3 to the power 4 into 2 to the power 2. Okay, did not understand. Let's say in the first go you did not understand anything. Let's read one more time. So this is 3 to the power 2 and to the power 3. Okay, so that means there is a 3 square inside the bracket and we have power of 3 of that. Okay, I did it this way. You can also say, okay, inside the bracket I have 3 square. Okay, let's see. Let me tell you how you can play with math. And I promise you guys that I'll make you play with math. That is my agenda for teaching you guys. Okay, I don't teach for any reason. I teach for making math a subject that kids start loving. Okay, now here I told you guys one approach. Say, okay, 3 power 2 and to the power 3 you multiply. That's one thing we have learned. But there is no compulsion for us to follow the same approach. Let's do it this way. 3 to the power 2 to the power 3 into 2 to the power 3. I'm just writing the question one more time. Okay, so let's do one thing. Whatever is simple, we'll do it first. Or 3 to the power 2. This is what? 3 into 3. This is 3 to the power 2, right? That makes it 9 to the power 3 into 2 to the power 3. Is this okay so far? This 3 square is nothing but 3 into 3. I am writing that is 9. That's fine, right? I can always write 3 into 3 or 3 square, or I can write that as 9. Correct?
Yeah.
And then I have a 3 to the power 4 into 2 square. Now look at this. 9 to the power 3 is what? 9 into 9 into 9. And 2 to the power 3 is 2 into 2 into 2. I am doing the dirty way, okay? Now 3 to the power 4, 3 into 3 into 3 into 3. And then I have 2 squares. Or let me do it this way, let me do it like a mixed bag. So I'm dealing with 9 and 3 separately, and 2 I'm dealing with separately. So here I'm saying 2 to the power 3 minus 2. This part is clear, easy, right? I will not worry about that. Here 3 into 3 is what? 9. 3 into 3 is 9. I'll pick a pair of 3 into 3, knock off one 9. Pick another pair of 3 and 3, knock off another 9. What I'm left with? I'm left with 9 into 2 to the power 3 minus 2 is 1. Yeah? Don't always look at 3 to the power 2 or any number to the power and then that is inside the bracket and then power. You can also look at 3 to the power 2 is nothing but 9. If somebody says this, 2 to the power 3 to the power 4 divided by 8 square. This is just a very small trick question. Now you look at this, 2 to the power 3. What is 2 to the power 3? 2 into 2 into 2? That is nothing but 8. So if you look at this question with a different lens, this is nothing but, you can always write this 2 to the power 3 as 8 and this to the power 4 divided by 8 square. Yeah? Are you guys with me so far?
Yes.
So this becomes 8 to the power 4 divided by 8 to the power 2. So you can always look at whatever you have inside this. If that is looking cryptic, look at it a little differently. Say, okay, can I knock up the power and make it look like a normal number? And then you can play with that. So if you by any chance, let's say you forgot that if I have power to the power and I have to multiply, You can always look at simplifying that and still get the right answer. Okay? Now, let's learn two more things very quickly and then we'll wrap up for the day. Wrap up for the week actually. If I have something to the power 0, what does it mean? 3 to the power 0, how much is that?
3.
That is one answer. How
0.
much? Okay, that is another answer. And I'm very happy to say both of you are wrong. No, I'm just kidding. I'm not happy when my kids go wrong. But I'm saying both the answers are wrong. Okay? 3 to the power 0 is 1. Because it will be 3 when it is 3 power 1. Any number to the power 0, any number to the power 0 except 0, okay, means 1. If somebody says,
What is the power of 0?
what is that?
What is 0 to the power of 0?
0 to the power 0, it's an undefined number. It is 0 by any means, but 0 to the power 0 is undefined. Because 0 itself is 0. 0 has no meaning. Yeah? So 0 to the power 0 is an undefined state. You can say 0 to the power 0 is 0, but it's not the right question to ask even. If somebody still asks you what is 0 to the power 0, you will say 0. Because anything to do with 0, if you have 0 and then you multiply it with 1 billion, the answer is 0. Okay? If you have 0, that you put power 2000, that is 0. You put power minus 5000, that is also 0. Okay? But in simple terms,
Okay.
anything, any number, the biggest or the smallest number in the world, if you give a power of 0, that has only one answer, that is 1. So if somebody says 5 to the power 0 equal to 1 billion to the power 0, that is correct. Okay? Any number to the power 0 is 1. Now, we have dealt with power that is positive, meaning you multiplied, you subtracted, you divided, whatnot. But let me first prove why do I even say that any number to the power 0 is equals to 1. Okay? Let me prove that for you guys. Let's say I have 3 to the power 2 divided by 3 to the power 2. Okay? How much that will be? It will be what? Whatever we have learned, we have both same base. It becomes 3 to the power 2 minus 2. Yeah? It becomes
Yes.
3 to the power 2 minus 2 is 0. Yeah? Now, we also know that 3 to the power 2 by 3 to the power 2, both are same. Let me make it simple. This is what it is. 3 to the power 2 by 3 to the power 2. That's what is the simplest form. Yeah? Are you with me so far? I'm writing this.
Yeah.
I'm saying 3 to the power 2 divided by 3 to the power 2. 3 to the power 2 divided by 3 to the power 2 is what? Is 3 into 3 in the numerator, 3 into 3 in the denominator. Correct? If I do tic-tac-toe, everything gets knocked off. That is 1. Yeah? Correct or not correct? Gitesh Pranav. Are you guys with me so far? I said 3 by 3 power 2 by 3 to the power 2. I don't even have to do this. I'm saying my numerator and denominator are the same. They will just knock each other off. So 1 times of 3 power 2 equals to 3 power 2. So answer is 1. Here, same thing. If I use the exponent formula, 3 power 2 divided by 3 power 2 will be what? 3 power 2 minus 2 will be equal to 3 power 0. And this will be the same as the value we got here. Okay? So,
1.
it's 1. So, any number to the power 0 equals 1. I just showed you how. If I use the same number here, it gives me 3 power 0. And it is also equal to, both are same, so it is 1. If I do tic-tac-toe. That's what I did here. So, any number to the power 0 gives you a 1. Yeah?
Yeah.
Now, one last thing. Not sure if I taught this in the class yesterday. If I say 2 to the power 3, you guys know what it is. Yeah? Do you?
Yes.
It is 2 into 2 into 2 or 8 or whatever you call it. Or you can just say it's 2 to the power 3. If I say 2 to the power minus 3, what does it mean?
No? I don't know. I don't know.
Pranav, any guess?
No.
No? Okay. Now, so you guys know 2 to the power 3 is equals to 2 to the power 3 or 2 into 2 into 2. Yeah? 2 to the power minus 3 is what? I can write this as 2 to the power 0 minus 3. Can I? Can I do that?
Yeah.
I can? Or now you look at this scenario when we were talking about, let's say any number to the power 5 divided by to the power 3. What I'm doing? I'm doing 5 minus 3. Correct? Here I have 2 to the power 0 minus 3. That means I can say 2 to the power 0 by 2 to the power 3. Can I do that? Look at this and look at this. Can I do that? Look at this and look at this. Is this okay to do so?
Yeah.
Yeah? And now I told you guys just 2 minutes ago, any number to the power 0 is what? 1 by this. Are you guys with me so far?
Yes.
So, what did happen actually? It had a power minus 3. What did I do? I brought it down and this minus power became plus. That's it. So, if somebody gives you 5 to the power minus 2, you can also write that as what? 1 by 5 to the power 2. The sign becomes positive to negative, negative to positive when you move it up or down. Okay? Now, let's play with this. What I said, if I have 2 to the power minus 7, I can write this as 1 by 2 to the power 7. And the same thing, 2 to the power minus 7 equals to 2 to the power 0 minus 7. Here this 1 is nothing but 2 to the power 0 and this is 2 to the power 7. If, let's say I have something like 3 to the power minus 5, I can also write this as, I can move this guy up. I can say 1 into 3 to the power plus 5. Because what I did, I just moved this guy to the numerator. So you can, any number with a power reverses its power to from positive to negative, negative to positive if you move it up or down on the numerator or denominator. Okay?
Okay.
So if I do this, it's not related, okay? 2 to the power 5 by 2 to the power 3. You know that how you can solve this. It will be 2 to the power 5 minus 3. Or you can also say, okay, fine, I learned something new. What I will do is, I'll move this guy up. And this is plus 3. So as soon as it goes up, it becomes minus 3. Now it's a multiplication, I'm not doing division. And when I do multiplication, my power gets added. So 5 gets added with minus 3. So this becomes 2 to the power 5 minus 3. Same thing, like what you would have done otherwise. Yeah?
Yeah.
Yeah.
So there are 4 things that we learned. One is, when you multiply exponents, the power gets added. When you divide exponents, the power gets subtracted. Make sure that the base is the same in both the scenarios that we talked. When you have power to the power, power to the exponents, it gets multiplied. And the 4th thing that we learned was, when you move the number with exponents over the line for changing from numerator to denominator or vice versa, the sign changes from positive to negative, negative to positive. And the last thing that we learned was, any number to the power 0 is 1. That's it. Yeah. There is nothing more than that you would need to learn for exponents, but we need to do good amount of practice so that it becomes a habit. I mean, we have to literally play with maths, okay? So whatever we have learned, I would give you guys some assignments, and I would want you guys to do those sums just to make it very easy for you guys. That's all. So I'll not give you a lot of sums. I don't do that, but I want you guys to work on this enough so that it looks like like a cakewalk for you guys. All right.
All right.
So that brings us to the end of the class. See you guys next Saturday, same time, 5 to 6. Yeah? Yes, Gitesh, you're saying something.